Hey there, everyone. Welcome back to our channel. If you're passionate about data science, machine learning, or just curious about how computers can learn from data, you're in the right place. Today, we're diving into a fascinating topic that can improve the accuracy of predictions and classifications in machine learning, ensemble learning. So, grab your notebooks and let's get started. But before we jump in, let me ask you this. Have you ever wondered why sometimes a single model isn't enough to make accurate predictions? What if I told you that combining the strengths of multiple models can lead to even better results? That's exactly what ensemble learning is all about. Let's explore this concept together. Okay, so what exactly is ensemble learning? In simple terms, ensemble learning is a technique in machine learning where multiple models, often referred to as learners or base models, are combined to solve a particular problem. The main idea here is that by grouping several models, we can achieve better performance than any individual model could on its own. There are two primary types of ensemble learning methods, bagging and boosting. Let's break these down. First up is bagging, short for bootstrap aggregating. The main goal of bagging is to reduce variance, which is a common issue in overfitting. Imagine you're trying to predict house prices based on various features like size, location, and number of bedrooms. If you trained a single complex model on your entire dataset, it might learn the noise in the data instead of just the underlying patterns. This could lead to poor predictions on new, unseen data. To mitigate this, bagging involves training multiple models on different subsets of the training data. Here's how it works. 1. From your original dataset, you randomly sample subsets with replacement. This means that some data points may appear multiple times in a single subset, while others might not appear at all. 2. Each of these subsets is used to train a separate model, let's say decision trees. 3. Once all models are trained, their predictions are combined, typically by averaging for regression tasks or voting for classification tasks. A classic example of bagging is the random forest algorithm. By aggregating the predictions of many decision trees, random forest achieves strong predictive performance while also providing insights into feature importance. Studies have shown that random forest can outperform a single decision tree by a significant margin as it reduces the likelihood of overfitting. Now, let's talk about boosting. Unlike bagging, which builds models independently, boosting creates models sequentially. The primary goal of boosting is to reduce bias, which is often seen in underfitting scenarios. Here's how boosting works. 1. You start by training a base model on your dataset. 2. After the first model is trained, you identify the mistakes it made. These are the data points that were misclassified or poorly predicted. 3. The next model is then trained specifically to correct the errors of the previous model, giving more weight to the misclassified points. 4. This process continues for a number of iterations, with each new model focusing on the errors made by the combined ensemble of all previous models. A well-known example of boosting is the AdaBoost algorithm. In one study, AdaBoost was able to improve prediction accuracy significantly on tasks such as facial recognition and text classification. The elegance of boosting lies in its ability to combine weak learners, models that perform slightly better than random guessing, into a strong learner that can achieve high accuracy. Now that we understand the two main types of ensemble learning, let's look at some real-world applications and data. Ensemble methods are widely used in various fields. 1. Medical diagnosis. In healthcare, ensemble learning can help predict diseases by combining the results of different diagnostic models. For instance, a study showed that an ensemble of various machine learning models could classify cancerous tumors with an accuracy of over 95%, outperforming individual models. 2. Finance. In the finance industry, ensemble learning is often used for credit scoring and risk assessment. By aggregating predictions from multiple models, financial institutions can better evaluate the creditworthiness of applicants and minimize the risk of default. 3. E-commerce. Online retailers utilize ensemble learning for recommendation systems. By combining different algorithms, they can provide personalized product recommendations that increase customer satisfaction and boost sales. To wrap it all up, ensemble learning is a powerful technique in machine learning that combines multiple models to improve performance. Whether it's through bagging, like in Random Forest, or boosting, like AdaBoost, the key takeaway is that the collective wisdom of multiple models often leads to better predictions than any single model can provide. If you found this video helpful and want to learn more about machine learning and data science, don't forget to give us a thumbs up, subscribe to our channel, and hit that notification bell so you won't miss out on our future content. And let us know in the comments below, what topics would you like us to cover next? Thanks for watching, and happy learning!